yoki boshqa mana bu kompyuterga ham sekit yuradi. Okay, welcome. Okay, we are live. Let me to check my microphone first.
Tuxum siznikimi?
Qaysi tuxum? Qovurib olavering aka. Yana olib kelamiz tuxum tugasa. Okay, we need to check our microphone quality first. So let me check the internet from my mobile, because I'm afraid of one thing is that there is a noise. I don't want you to have that noise. Okay. Okay. I changed the switch here. Maybe it helps. Okay, now. Yeah, hello guys. Maybe now better, right? No. Okay, now. Yeah, hello guys. Maybe now better, right? No. So this is a noise, right? Why there is a noise? Hello. It doesn't work. I don't know. It doesn't work. Hello guys. How are you? Can you hear me? What about now? So now we need to check it. So YouTube, quickly. It will not take that much time. So YouTube, quickly. It will not take that much time. Okay, good, awesome. Awesome. So we are ready to go. Oh my god.
We are waiting for
Okay, let me change my background. Oh, okay. This is better. We are in Uzbekistan now. We are now in the mountains. Okay. In last stream we have finished this hardware stuff. We have built a computer, a control unit, and etc. And then we have moved to software. We didn't expect to have software, but it turns out we have a software part also, which is cool. So now, and then we did a machine code, we did assembly language. In machine code, we just write by ourselves 1001 manually, and we did four. Here you can see 4 instructions. We did 4 instructions manually by like changing 0 to 1 or the 1 to 0. It was good, right? It was something like that. And then we did an assembly language. We created a small language where we just write this d plus a, and it will map to this value. And we did the same for other things. So now we have, you know, 1, 2, 3, 3 columns of this code. This is our syntax, okay? So this is our language. We call it assembly language. Very low level language. And now we are building assembly program, okay? So, okay. As you may have realized, writing programs in binary machine code is quite tedious. Means not that much easy, not straightforward. You need to be, you know, really patient. To make it easier, we use assembly language, where the instructions are written in text form. Each line in the assembler text corresponds to a machine code instruction. An assembler program then translates the text into machine code. In this mission, you will write a program in assembly code. Okay. So our task is to write assembly code. Write a program in assembler which causes the lamp to blink at least 3 times. Okay. We need to write a program which will cause the lamp to blink 3 times. The lamp is memory mapped to the address 7FFF, bit 1 and 0. Bit 0 turns on, turns off bit 1. The external device is only affected when bit is changing from 0 to 1. Okay. What? No. Why I cannot write? So what? Why is it not working? Why it's not working? Maybe I need to restart. What? Okay, something strange. Something strange. Okay, we have 5 views. Oh my god, why it's not working? It turns out our web browser is dead. It died, unfortunately. It died. It's bad. This was our program, you know. This was our browser. Let's see. Level assembler. No, what are you saying? Okay, now we have now we are working. Assembler code. Okay. So our task is to reach to this address and to change its value from 0 to 1 or from 1 to 0. Make sense? Makes sense. Need the help. Syntax is destination equal to calculation jump condition. Destination and jump conditions are optional. Okay, we have these instructions. This is our language. We need to go to the destination. This address. Okay. Again we have problems. Command. Our destination is what? It is this address. 7FF. Why? 7FF. F equal to. Can I say like this? Equal to 0. Let's run it. Why it's so baggy? No. So guys, we need to reach to this address, right? We need to reach to this address and make this content 0 or 1. Address is destination. Address is our destination. Very bad. I don't like you. T equal to T plus 1. Run. Okay. This is our D, right? But I don't want for D. Insert. Seven FFF is our address. What if I change A equal to 0? Well, okay. Star A equal equal to star A. Run. Okay, how I can go to this destination? It means this lamp is on, guys. It means this lamp is on. Okay, I can say, like, I can define for a register. PC is a counter. But what I can do more? No, we have a formula, right? Destination equal to calculation, and then jump condition. Oh, it has this small bar to see. Oh, good. What? Don't report. It closed? No, we need to go back. NAND game. NAND game. Insert. Define C equal to 7123. Tick, tick, tick. Run. Our instruction is changing. If I comment this out, then instruction is still changing. No, we are missing something. We are missing something. We are missing something. Assembly language. Okay. We need to reach to the address, right? Why it's not working? t equal to 0, right? Oh, I don't know. T equal to 0. Zero means this one, and D equal to means AD A star. See? A equal to 2. I thought something like this. What? Who changed this one? D. Destination is D. D plus 1. D plus A. No, we need D plus 1. Okay. So here, we don't have memory, right? We are not doing any memory stuff. Here, we are using this stuff. Okay, but we can use this. This is destination. This is operation LU. This is comparison. A star. What about if I say, star A equal to 1. Run. One, 2, 3. I'm confused in how to access to this address. Value in RAM at the address contained in A. Okay. What about if I assign A as 7FFF and then start A equal to 1. Run. Tick 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 tick. Is it working? We have registers. Okay. We need to use 0x, I think. This is our error. Now tick, run. C. So in order to write to the memory, it's good to it's right to include this address, memory address, but we need to also include this prefix. I can do a equal to 0, e star equal to 0. I can say a star equal to 1, star a equal to 0, star a equal to 1. Can I do like something like this? Check solution. Why it's not closing? Strange. No. I'm pressing X, it's not closing, but now it's closed. Current diagram doesn't comply with the specification. Run 100 clock cycles, but didn't detect any lamp blink. Are you sure? Maybe you know what we can do? We have address, and we assigning it as 0, as 1, as 0, as 1. It is a blink, but it seems like they need 3 times. Zero, a equal to 1. Let's check now. Then we need to include, some breaks between, something like, okay, we have here this thing, so now we can, change it, like we can say d equal to a, and then a equal to a minus 1, a equal to a plus 1. Check solution. Run. We don't need to see. I'm assigning 0 and 1, and then 0 and 1, and 0 and 1 3 times. I'm adding here some kind of condition. Or maybe I can just change the a, No, we need some, This is lamp, right? Tick, 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 tick. On. Or off. Off. On. Off. On. On. Off. On. Okay, we have lamp address. We have defined the address. We are writing to the address specific values, and they are working. And this is showing on and off. But how to do the 3-time break? Isn't this logic fine? 0, 9, 0, 1, 0, 1. This is bleak, right? This is bleak. This is bleak. The external device is only affected when a bit is changing from 0 to 1. Why it's only on is showing, off is not blinking? Let's see. Tick, 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 0, 1, 0. Merak yapıp oh, see, it's only first is blinking, second one is not blinking. So second one is this is first bit, this is second bit. If I assign 2, let's see how it will be work. Tick, 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 tick. No. Oh, now maybe, huh? Insert mode. Run. One more time. Okay. Check solution. It turns out we need to set it to the 2. So this means we are just setting it 2. We don't need this stuff. We don't need this stuff either. It's saying you cannot do it same time. You cannot write directly. If I cannot write directly, then why? First assign to A. It's saying to assign first to A. Okay, I will assign to A then. But A is occupied already. This is A. Last time we did, you know, just did something like this, and why it worked. I'm not getting very well this stuff. Why D is screaming like this? Only A can be assigned. It seems like, you know, like A equal to 2, so D equal to 2, and then Y. I can say it's D, I can say it's D, say it's D, and now run. Now it should pass. Okay, now we understood. Now we understood that we cannot directly write to the D or A star. A star A. First we need to write to A. A is like the register number 0, kind of. Next level. Whoa! We have virtual keyboard. Isn't it awesome? We have virtual keyboard, and we have assembly code, and now we have a computer, and now we have a task. Let's build this one. It's not that difficult. Okay, write a program in assembler which write keyboard input into memory. The keyboard input is a memory mapping to address 6000. Write the first character typed at memory address 1000. Second typed at 1001, and so on. Note, a key will usually be held down for much longer than a clock cycle, but should only be registered as a single input until the key is released. we have input, see? Okay, I need to exercise. I need to do exercise. So now we have much more experience, right? So we need to assign A. Let's say A is equal to the address or X 6000. T equal to A. Star A is RAM. So when I press, what value is changing? I mean, value at address 6000 is changing. So A star now goes to this address and read it, right? I can say A star is equal to 0, and then D equal to star A. Oh, run. So reset, tick. D equal to 6000. A equal to 0 means we have this value for A now. Now it should be 0. This doesn't make it 0. It should make it 0, no? Again. Tick, tick. 68, right? 69. And 69 should assign to D. Okay. We need to write the input which comes to this memory address and write it to the starting from 1000 and etc. T equal to A. I don't need this T. So A star has a value now. I mean, it stores the content. So we need to write this content to the destination. What kind of destination? Something like if we assign D to A, so we can increment D easily. Really? Are you sure? And then A star. We take the value from A star and we write it to the D. Let's say to the D. And then we make A equal to D. No, we make then A equal to let's say C. Target. Why that target? C. Okay. No. We cannot assign C. Okay. Target equal to A. Define. No. Oh, we are using define in wrong way. Define target so now we should be clever. Now we should do a clever thing, you know. Our A should be this one, so the star A can access to this address, to the address of 0068, and now we need to take this 0068 and write this value to another address. So address value is 1000. So we can store the A star in the D, and then A is equal to target, and then A star equal to D. Now we write to the target. Now we wrote to the 0x1000. And now what we should do? Now we should increment. A equal to A plus 1, D equal to A equal to 1000, and like this. Expected memory 1000 to be that value. How can I see that address? A is 1000, right? Now D is this one, and I say this is not the, this is writing. our problem is easy. See, the problem is that we read from the 6000 address from the 6000 and write the content to another address. Address is defined, it is 1000. Until a key. Okay, maybe we are not satisfying this one. See, we are not satisfying this condition. A key will usually be held down for much longer than a clock cycle, but should only be registered as a single input until the key is released. What is a clock cycle? This is one clock cycle, second clock cycle, third clock cycle, and so on. So we are getting A, we are assigning D to A, and we are changing A to the A target. Our problem is that we should not assign like this. I think this is bad. Now we have start A equal to D, A equal to A plus 1, we need to include a condition maybe. Okay, we should think carefully, guys. We should think carefully. This is a small problem. This is not big problem. We need to figure out. Okay, hi, what's up? Hello, what's up? It is morning in South Korea. It's 7 a.m. It is summer, it is August. Today it is maybe cloudy day, expected to be a cloudy day. So we have a D equal to A star. Okay, we have alarm sound. Alarm. Someone is sleeping. Okay, I'm a bit confused. We can use, like, it's not a big problem. We can use, we can use condition. We can use arithmetics to fix this stuff. The problem is that comes when it comes to this part. Okay, do you have any idea? A key will usually be held down for much longer than a clock cycle, but should only be registered as a single input until the key is released. Yes, it is a problem. It is a problem. You have A, you have a target. We don't have another register. Let's see this assembly hub. So we can do D plus A, D and A, jump condition. Oh, we have 110 views, 12 viewers. Okay, we are growing, guys. So let me tell to people who are coming late, who joined just right now. So we have registers. This is simple computer. We just have A register and D register. This is counter, and we have a clock. So each processor has a clock, and this internal means a RAM, a memory. So I can access to the memory by using this star A variable, and then we have a memory address. So if I assign register A to the certain memory, and then I can read the value of that memory address. So if I assigned A is equal to 0x means hexagon, 16-bit value, 6000. Oh, okay, I'm going 6000. And if I say this one, it goes and read from that address. Okay, it goes and reads from that address and assign to the D. But when it should do that? Only when it's not repeated. Can I say something like, like this and star A minus D is larger than 0? Not equal to 0. Have I implemented that stuff? Oh. Okay, I need to say GLT. Okay. I just write GLT or etc. I need to go to this one. GLT. Not equal to GNE. Okay, guys. Do you think this is correct? So GNE means put to the D the A only if the A star is not 0. Okay, I'm sleepy, guys. I'm sorry. I'm a bit sleepy. Check solution. No, not check. Reset. Tick, tick, tick. If I tick, it will run until it will not run. So Address is 0. Okay, let me to make address 0063. Now when I press click, this should run, and I expect that this D should be updated to this value. Click. Ah, it's not updated. GNE not equal to 0. Are you sure? So A star then is not equal to 0. Now 00063. Okay, not equal to 0. I mean, we should say not equal, not, it's not, we should not use 0, you know, we should use another value. Our problem is that usually when we press once a keyboard, we have not only one clock tick, it may be several clock ticks. So we should ignore these clocks and say it's just one input. So we can say, you know, A equal to target. No. I'm using this A equal to target, A star equal to D. Why? It means I'm writing to this address, this value. Should I write to that address? No. Before writing to that address, I should, you know, make a condition. But what kind of condition? Ideas, please to chat. So I am pressing the C button. It's 0.063, and it may run for several clocks. Maybe I am looking to the problem from different side. Then this star A is the address at target minus T. It should not be equal to GNE. It should not be equal to 0. Yes. No. I should say, you know, star A equal to D only when A minus D is not equal to 0. I want to say write D to this place, this target place, this A target place address, only if this A is not equal to D. Okay, it's a bit confusing, I know. A bit confusing. Is this saying a mistake? A star A minus D G and E. A equal to target. A star, we have a D. Okay, this one will store value to the A star. Look, it's saying here, calculate D minus 1. If I do something like this, will it work? Let's check it. Reset. Click, 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 click. What? Reset. One, two, three. Aha, G and E. Now D is equal to 63. What if I say just 0, 0? Why it's hard? Do we have any hints here? Hints? No? No hints? That's also fine. That's also fine. That's also fine. We should break down the problem into small parts, okay? We should break it down. Okay. This is our cycles, clock cycles. When it comes here, I press a key. It's running this one, this one, this one, this one, and then I release. When I release, then write. If I don't release, don't touch, don't write. It should be that kind of logic. I'm really, like my mind now is like, becomes like, no, because I'm used to write high level code. So now like my brain is not working in this low level. It's going like, it's trying to use some kind of while loop or like for loop or some kind of this Python logics here. But it's wrong to use them. There's efficient way. There's more easier way. Straightforward way. But we need to find it. Now we are reading A star only in clock number 3. And then we are writing it to the A star. No, we should not write to the A star. We should write to the star A only when it is released. maybe you can say star a equal to d star a minus d. I cannot equal to the d. I can make a plus. I can make a minus d. If only it is not equal to 0 when we do this kind of operation, star a minus d, when it is not equal to 0, when we subtract star d, the output should not be 0. Only then we can say this thing. What? No. We have problem. Anyway, it doesn't matter. No. Reset. Zero 165 and t will be 0.65. Yes. Why it's going to there? No, it should not go like there. It should not go there. Now what? Star A is that what? What is that? 0.0065? 0065 minus 0065? It is strange. I don't like it. Okay, we need to write to the D only when it is not 0. D and E. Actually, we should put it here, right? Minus D, G and E. No, I need help. I need a hint. Our solution doesn't work. Our solution doesn't work. Our solution doesn't work. We need to find something new. And I also need to take a bath. It's so hot. So hot outside. And inside also hot. Okay, this task is much harder than previous tasks. Because we are not seeing the, like, we don't see proper way to do that. Star A is equal to star A. What we can do? What we can do here? Do I need any condition? Yes, I need a condition. What kind of condition? The value the content value will be the same for several clocks. Will stay the same. And only we should write only when it changes. Only when it changes, okay? Make sense? We write only when there is a change. We write to the A star, the D value, only when there is a change. But how I can go to the change if A is 1 is I cannot read two things at the same time. Okay, then we say a equal to the address, and then star a minus d should not be g and e, should not be equal to 0. How keyboard works: when you press one time, it just prints 1, right? But I'm holding my keyboard right now. When I take my hands off, finger off, it's not, it's just write only once. So this is the logic. We should implement this logic. See again, B, raise my fingers, just one B. I'm pressing it, right, and raising. Okay, it should be something like this. Okay, it means yes, we should write to the D anyway. We write to the D, we write to the memory, and then we need to check this A, and minus D, G and E. Zero 1000, 0 6000. I write to the D. I assign A as the target. I write to the A at D. I don't know. I think this is not necessary. I mean, this is optional. We should update the D only when the A star is updated. We should not touch the D A. What? What happened? I don't know. Insert. What happened, guys? Oh, 7:31, guys. It's time. It's time. It's time. I'm sorry. It's time, guys. It's time. It's time. So I need to go. I need to go. I need to push my limits today. I need to work hard today. And then A equal to the x 6000. D equal to star A if G and E and star A minus D, G and E. Why error? Why is this error, guys? Maybe plus? No, you don't understand, Sardor. You don't understand here. So write this A star to the D only when it is not repeated. Press A for 10 clock times. Expected memory to be that one. How nice is the memory? No, it should work. G and E. Okay, guys, thank you very much. It's 7:35. I need to go. I need to have a bath. It is today Wednesday. Oh my god, today it's Wednesday. Time is flying. Have a good day. Thursday. Sorry, it's Thursday. It is Thursday, 21st August. Guys, okay, bye bye. We will fix this next stream. I don't know, my brain doesn't work, or I couldn't fix this one. So, see you guys. Okay, bye bye.